Okay, so the second part of 5.4 has to do with identities. And so,
first one, we talked about the polynomial identity. And that's for the inner cosine squared plus sine squared plus 1. We used to draw the circle, the polynomial circle, draw a column, times is 1, and x is the cosine, and y is the sine, because it's x over r is 1. Okay, so the right triangle is x squared plus y squared is 1. Okay, we can use this identity to get algebra forms, and one which uses the tangent, and one which uses the cotangent. And so I will use these as necessary to solve equations, probabilities, okay. So it's just that you can move these around. For example, even though 1 plus tangent squared plus secant squared theta, you can also say, oh, well, if I move the tangent to the other side, then that means that secant squared minus tangent squared equals 1. Okay, so you can algebraically look like this. So if what you need is, for example, up here, we have to have this one here, here. I'll also be able to cosine squared. Sine squared. So we can do just probabilities. That's the reason I can put all of them together. If I can put sine when it's going to do, if I put cosine when it's going to do, I don't know what. Okay? Now, I need only conjugates. Sine. X in the R. First we work the candidate, we will have the line at the let's see what for the simple cosine. Cosine, which is the reciprocal of sine, is 1 over sine. And the cotangent is 1 over tangent, which is also the cosine of sine, which is this guy, foot, reciprocal. And what we do want to use those will create some identities. So just as we often to simplify algebraic expressions, it is often necessary and helpful to simplify trigonometric expressions. To do so, we realize the definitions and identities will be established. All right, here we go. We're going to simplify this. So we see this as the secant, and we see that as the secant over the tangent. Okay, so first of all, let's just see if we can move it in terms of sines and cosines. And I want you to refer to this list above as we go through. One has on the side of the notes that you're taking. So the secant is actually the cosine theta. The tangent is actually sine theta over cosine theta. And what we can do is most likely is treat this as a fraction divided by a fraction. So we would do the cosine theta by the simple. So the cosine in that side, it's like the fraction expression. And then those two cancel out, and left with 1 over the sine theta. What we also know now, we can have here, the sine is the same as the cosecant. So the final simplification would be cosecant of theta. Okay, so it's simplified because it's going from a fractional potential fraction of just a simple term. Okay, let's try another one. Again, we're going to see what the sine of the cosines are. That's our first trick. So cotangent, well, let's see, that's 1 over tangent, but it's also cosine minus t divided by the sine over sine. You can get that from the identities. Sure. So cotangent is cosine over sine. Cosecant is the reciprocal of sine, so that's 1 over the sine. You can check me out on these. Now I'm going to see here how to take, I'll do that in different colors. So let's keep the cosine of t over the sine of t. And it is going to be the reciprocal of those products. So it's going to be the sine of t on the right, cancel the last two, cosine of t. So this
Simplifies to this nicely. Okay, let's see if we can do another example here. Oh, okay, this time we're asked to prove the identity. Now, what happens when you're asked to prove an identity is you start with one side or the other, and you turn it into the other side. You can't go back and forth. You have to start on right and go to left, or left and go to right. So we're going to start with left and go to right. So we'll have 1 plus the cotangent of alpha, they're using this time, over the cosecant of alpha. Now again, I'm going to always try to start with the cosines and the sines. So let's go with 1 plus, now cotangent is the reciprocal of tangent, so that's going to be cosine over sine. Mine look like fishes, my alpha. And cosecant is 1 over the sine. So 1 over the sine. So that doesn't look really great yet, but let's see if we can fix this up a bit. Let's go ahead and times by the reciprocal of the denominator. Okay, so let's keep this guy and times it by sine of theta or alpha over 1. Okay, so that's everybody okay with that? Now what we're going to do is, we're hoping something cancels out here. So we're going to distribute this to both of these guys. All right, so 1 times the sine of theta, that's easy enough. That becomes the sine, sorry, it's not theta, it's alpha. We'll keep it over 1 for now. Okay, so that's what I just did right here. Plus, now I'm going to do sine of alpha over 1 times cosine of alpha over sine. So are you catching this? This one's going to here. So now this times this is right here. Okay, now hopefully, yes, I can definitely cancel those, which leaves me with the sine of alpha. I can put it over 1, but let's not. Plus the cosine of alpha, which is what I wanted to end up with, because that goes back to this. All right, so one more time I went through the steps. Were first change the cotangent. I'll do it in a different color. Let's go with pink. Okay, so the first thing we did is we changed the cotangent to cosine over sine. Then we changed the cosecant to 1 over sine. Next step was, let's do green, we took the 1 over sine and we times by the reciprocal. Boy, this is going to be a kind of strange looking at the end. So then we took the, let's go to a light blue skinny, and then we distributed that sign to both, and we ended up with this. And then the final thing we did was, let's go with blue, was to cancel the signs out, and we were left with our yellow, this sine and this cosine, and that's what we have. Wow, okay. Oh, good, another one. All right, so let's go with sines and cosines again. So tangent is the sine over the cosine, and secant is 1 over the cosine minus the cosine. I'm going to put it over 1 because I'll probably have to get the common denominator there. All right, so let's combine the bottom two. Okay, so we took this. Let's combine these two with one denominator. So if I times this by cosine of t over cosine of t, okay, then I'm left with, the numerator stays the same, sine of t over cosine of t, but the denominator will become 1 minus, now cosine times cosine is cosine squared t over a common denominator of cosine t. All right, so I'm combining these two fractions to 1. All right, so now let's see. If I go to my Pythagorean identities, I know that sine squared plus cosine squared equals 1. So I also know that sine squared is equal to 1 minus cosine squared, right? So I'm going to change this 1 minus cosine squared to a sine squared. Okay, are you ready? So we're going to keep our numerator, sine of t over cosine of t. And I'm going to, do I have a little bit more room? Yes, I don't need, there we go. Okay, and we're going to divide that. Instead of 1 minus cosine squared, I'm going to divide it by sine squared over cosine t. Okay, now I can rewrite this as sine of t over cosine of t times the reciprocal of that puppy, cosine over sine squared. And the reason I'm doing that is so those will cancel. Woohoo! And oh, actually, one of these cancels with one of these. And I'm left with a 1 on top and a sine of t in the denominator. Okay, everybody catch that? Canceled those. And 1 over sine is actually cosecant of t. Boy, we definitely simplified that. Okay, that was a lot of work. So again, the steps were change it to sines and cosines, get a common denominator, times by the reciprocal, oh, make a Pythagorean substitution right here, then times by the reciprocal and cancel out. Okay, and that is the end of this video. So you can go ahead and try my open math and bring your questions to class.